Quick Draw is a great game, and it's a great way to learn a little bit about artificial intelligence and the bias that these models have below them. So we're going to start by playing a game, and it's going to ask us to draw something, and we're going to do it. And as we try and draw, it's going to guess. So, oh god, mosquito. We give it a try. So we're going to start with a little snout.
I see volcano. Or lollipop. Or ice cream. Oh, I know. It's mosquito.
It got it. And then we go through a bunch of different ones.
I see green bean. Or shark. Or deer. Oh, I know. It's palms.
So it goes through different drawings, and it tries to guess what these drawings are as we play. And at the end, we get to actually look at the data and see what is happening behind the scenes. So what I really want to talk about when it comes to this is lightning and how it recognizes a particular drawing. So let's go to the data set to see how this is working. So they have a data set of all of these different drawings, but not every drawing. And it knows in the game how to make all of them. So let's say we were going to go to lightning. These are all of the 141,000 ways people like you have drawn lightning. And every time while the game was live, it was collecting all of these different drawings and adding it to the data set. So we can click on this one and see that in Germany, January 26th, this lightning was drawn and added to the data sets. And one thing that you should be aware of is if we were to play the game and try and draw lightning, even if it wasn't the challenge, look what happens. Squiggle.
I see lightning.
Boom.
Or
Easy.
arrow.
But what if I draw it instead of from the top down?
I see lightning.
I draw it from the bottom up.
I see zigzag.
Different
Or mountain.
guess. It might
Or
still get
squiggle.
it. Or maybe not. Maybe I have to add a little more.
I see arrow. Sorry, I couldn't guess it.
So depending on how you draw it, the system is going to guess differently based on all of these different drawings. And you might even notice that most of these drawings for lightning specifically start at the top. As I scroll down, they're almost all from the top. And if I mouse over it, top, 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 they're starting at the top. So the training starts to know that if there's some sort of zigzag starting from the top, then it's probably
I see lightning.
lightning. But if I start from the bottom, even if it's the same
I see
shape,
mountain.
it doesn't get it
Or
the same
zigzag.
way. Because people draw things differently. Now, I could probably still get it to recognize lightning
I see line.
from the bottom.
Or mountain.
Maybe a cloud.
Or asparagus. Or lightning.
Boom. The cloud
Sorry,
plus the
I
drawing.
couldn't guess it.
But it's just a little
I
zigzag.
see lightning.
It's able to get it because it learns people draw it a certain way. So all of these different drawings are part of the data set for lightning. And what's really cool about that is, it knows based off all these different drawings. The smaller the data set, the less likely it is to get it right. And the smaller the data set, the more likely it is to, let's say I drew this for lightning. This is my drawing. Imagine it was lightning. That's a lightning bolt.
Or smiley.
That's being added to the data set at the end, and it's not a very good drawing. So you have to clean the data to make sure that when you go in here, all of these drawings are in fact lightning. You don't want to see a random smiley face in here. So they did clean the data, and it helps make it good, but it's still biased information. And I want to show you, just an example of biased, which is just unfortunately a true thing, and that's if you ask one of these models, make me an image of a classic school teacher. Like, imagine in your head what you think a classic school teacher is, and these are just some of the things that it's going to generate because its training set, like the training set of this lightning, is populated with things that kind of are generalized and stereotypical and not always the best thing, but it's just what's true. So here are two more images of, classic school teachers. I asked it 5 times. This was another school teacher. And then I want you to think, what is Microsoft CEO look like? And I asked it twice, and it gave me a white male in like late 30s, 40s. Again, kind of the same thing. So it's very biased unless you give it more context. And that's not such a good thing. So we have to be aware that when working with these models, this is something that we need to know so we can adjust for the bias that's in there, you know, and specifically tell it, now make it more accurate and generate any possible CEO who can make it. I don't know. I'm trying to add more context. It doesn't need to be what the expected image is. You have to add more context. And it will generate anything, but if you just ask for something simple, it will likely give you something more simple. This one's literally just trying to recreate that current CEO, which is a lot more accurate. It doesn't exactly look perfectly like him, but it definitely looks more like him if we go Google his name. But you can see how the original bias, actually is pretty good. You can see how the original information clearly biased. So you got to be aware of that. And just for some fun, I decided to ask ChatGPT, so it's generating a most likely answer based on its training set, and it's responding by saying that Quick Draw from Google can help demonstrate how AI can learn to recognize patterns from a lot of human data. That's true, just like Lightning, lots of drawings. And each doodle submitted contributes to training the model, helping improve its ability to recognize new drawings. That's true too. They've closed the experiment since, but that's pretty good. So this information I would trust, but only trust it knowing that it's biased because I know that it is true. So you got to have that background information. Crowdsourcing. This game highlights how large data sets, especially those from everyday users, can increase the AI's training. Millions of drawings from people across the world provide that's true. And AI models are constantly getting updated by more, human tuning of what it should and should not do. It shows how AI and humans can work together. We need to work together. It's an incredible tool for productivity. And it may not always do it correctly, but the interaction provides insights into both the creativity and limits of machine recognition. Pretty good answer if you ask me. So, is it biased? Absolutely. Does that mean you can't trust this information and help you explain it? Absolutely not. You should use it, and that's why we're learning about it. Hope you guys enjoyed this lesson, and I'll see you guys in the next video. Peace.